So in this exercise, we're going to look at polylines and how polylines work. So up here on our Home tab, this is where polylines are located. Polylines can be made up of lines and arcs, and they can all be joined together. And there's various reasons why you're going to want to use polylines. So if you have lines and arcs that are connected together, so say I have a line like this, and then I have an arc that starts here, goes out like this, comes up like that, and I want these to become a polyline together. I need to use the p-edit command, or polyline edit command, and I believe that's up here in this drop down someplace. I'm not sure which one it is. It's right here, edit polyline. So p-edit, basically the way that it works is you'd pick the line first. It asks you down bottom here, do you want to turn it into one? We'll say yes. And then polyline edit has many different options here available: close, join, width, edit vertex, fit, spline, decurve, line type generate, and reverse and undo. Okay, so what we want to do is J for join. So basically I come up here, whoops, bombed the command. I'll pick that, hit J for join, and then pick this, and then this becomes a polyline. And we know it's a polyline because when we select it, it's all one object. Okay, so if I'm going to draw a polyline from scratch, I just type in the command polyline, and I can start drawing a polyline like this. So notice that polyline down bottom, watch the options down here. It says P-line, specify next option, or arc, half width, length, undo, and width. So if I just go like this, you know, I'm just drawing lines as polylines. When I type in A for arc, it will make an arc that is tangent to the last line, so I can kind of do this thing, and then the next arc is tangent to that one, and you can kind of see we can kind of do the spirally kind of thing like this, and just kind of go like this all the way down like that, and that's one polyline. All right, so there's many different advantages to using polylines. One is the offset command. One thing that is a polyline is a rectangle. Even though a rectangle shows up as its own command, you know, when I pick this like this, this is actually a polyline object. It's four lines connected together. If we look at the properties, notice up top it's called a polyline. It's not called a rectangle, it's called a polyline. Okay, even though the command originates as a rectangle, it actually generates a polyline. So what are some practical uses for a polyline? Well, one is to draw like a floor plan, for instance. If I was to draw, you know, a house, and you know, I was drawing it with dimensions here, I'm just going to sketch something, and I kind of come up like this and come over like this and come up and over and close this over like that and hit close. This is now a polyline. So when I want to offset this, it's very easy to use the offset command and give it, you know, an offset distance of 6.5 inches or whatever the wall thickness might be. So I can kind of do that sort of thing, and I immediately have, you know, walls that are, so that's a very big time saver over offsetting individual lines. So if I use that same example with lines and kind of went like this and went up and over and up and over and back like this, okay, and I go to say offset, oops, offset. Now I have to pick each individual line, and I have to go in and fillet all of those. So it takes, you know, a tremendous amount of time longer, whoops, than it would normally take. So if I go in here and fill it like this, and fill it like this, okay, and fill it like this, and fill it like this, I mean, just look how long that's taking me to do that. Whereas if I drew it once, offset it, so then once you have this, and I was going to put in interior walls, then all I have to do is explode the interior one. Okay, use the explode command. Explode will just basically take your polyline and explode it into its individual parts and pieces. So if it's made up of 20 lines, you'll get 20 lines. If it's made up of lines and arcs, you'll get lines and arcs. So once you explode it, now I have individual lines that I can offset and use. Okay, so there's that. When you're using, say, a rectangle, all right, and we use the offset command on here, okay, it will offset outward concentrically or inward concentrically. Okay, if I take this same rectangle, okay, over here, there's a variable called offset gap type. Okay, offset gap type. Notice down here at the command line that it's putting it in down there, offset gap type. There are two variables for that. It can either be a 0, which is the default where we create square corners, or it can be 1 where we have a rounded corner, or 2 where we have a chamfered corner. So if I put in 1 for offset gap type, and we use the offset command again on this, watch what'll happen this time. We'll click that, offset, click that, offset. And so you can see how that's doing that. All right, if I click the inner type, I don't get that because there aren't any radius solutions on the inside. The radius gets too small, so it won't work. Okay, so if we use that same rectangle here and copy that over to here, okay, and we use offset gap type again and put in number 2, okay, I'm going to use the offset command again, and this time what we get are chamfered edges. Okay, and then eventually that chamfer ends up kind of being a little bit rounded. It's kind of strange looking, but I don't use that too often myself, but it's available anyway. So that's a variable that can be used with polylines to create some interesting looking things. So getting back to polylines again, what if we want to create like a big giant arrow head? Okay, so when I use polyline, I'm going to come in here and click once, and I'm going to draw her up like this. But before I click the second time, notice we have arc, and then we have half width, length, undo, and width. Okay, width and half width work basically in concert with each other. Width is the total width of the actual polyline, how thick it is, and half width is just that, it's half its width. So, you know, I don't know how thick I want to make this, but let's see, I'm going to go with a half an inch, I guess. So we'll do W for width, and I'll say 0.5, okay, and it asks for a starting width and then an ending width. That way I can have tapered arrows or tapered lines. So if I do that, notice when I click that, I get this thick line that gets drawn. So I'll click again like that. Now I want my arrowhead to be bigger at the bottom and narrow at the top. So I'll type in width again, and this time I'm going to put in something really big like 5, okay, and then the ending width is going to be 0. So we do that sort of thing, and we get something that looks like that. So it's either a tree or an arrow or whatever, but this is one polyline. Okay, so that's how we can create these big arrowheads and things like that. So what other things can we do with the polyline? Well, let's try some other experimentation. I'm going to start right here with a line, and the only other options in here are length and arc. We've already covered width and half width. So length is kind of an old holdback from the early days of AutoCAD. So when I type in L, it asks for the length of the line. So if I type in 5, for instance, it'll go in the direction that I was traveling, 5 inches or 5 units or whatever. If I type in 6, you can see it's kind of going in that direction. If I type in 4, it's going in that direction. If I type in 2, it's going in that direction, and so on. But now that we have dynamic input, we really don't have to, worry about that so much. So, because if I'm drawing a line like this, I don't have dynamic input on, but I can put that on. So, I could just basically type in, okay, I'm going at this direction, I want it to be 6, and it goes up there 6. So like that. I want to go down here at 60 degrees, 65 degrees, 4 inches. I can do that sort of thing. So length really isn't that useful anymore, but what is more useful is the fact that you can, let me turn off dynamic input again, get in the way. Alright, so once I have this first line established, if I type in A for arc, okay, any arc that comes off of your polyline is going to be tangent to that line no matter where you drag it. Okay, it doesn't matter how long the arc is, how you bend it. Notice it's always tangent, okay, by default. But notice also down at the command line, when I go into arc, I get a subset of arc commands, okay? So I have angle and center and close and direction. Again, we have half width. We have line, so we can go back to lines. We have radius, second point, undo, and width. Okay, so let me just draw in an arc like this. And then my next arc, maybe I don't want this next arc to be tangent, okay, but I want it going at a specific angle. So if I type in A for angle, okay, I can say, well, what's the included angle? Well, I want to have the included angle go, I don't know, in this direction like this. So when I do that, you can see that it creates that angle, okay, from there. So I can kind of put that up there like that. And then the arcs will continue tangent to the other arcs. Quite honestly, these sub commands in the arcs are relatively hard to use. But it's kind of fun to experiment with them to see what they actually do. Center, it can be quite useful. So say, for instance, I want this arc to go around the center point of this arc. I could type in CE for center and come down here and pick that center, and notice that that arc is now coming like this across here like that. So I could do that sort of thing, and then I get my tangent arcs again. Okay. If I type in D for direction, it says specify the tangent direction for the start point of the arc. So the tangent direction, okay, so I could say, well, I want it to be tangent almost like 90 degrees from that one. And now you can kind of see what happens there. It kind of puts that in like that. And then I get these, tangent lines coming, tangent arcs coming back out again. So I can kind of do that sort of thing. So, play with this. If I type in R for radius, you can set a specific radius. So if I want my arc to be 10 inches and the radius to be 10 inches, okay, that's what it's going to draw. Okay, it's going to draw a 10-inch radius arc off that last point. So then I can kind of come back in here like this. And then lastly, we have the close feature in here where I just type in CL for close. I can't just type in C because we have center as well. So it's either CE for center or CL for close. So if I type in CL for close, it'll close to the very first point that we started. So I'll type in close like that, and it finishes that up. So once you have a closed polyline like this, we can get information from this. We can get information as far as how long the perimeter of this is and how much area is within this closed polyline. Okay, so if we come up here to our utilities, we can come up here to list. Well, where is list? It's not in here. Okay, well, we'll just type in list. So if we use the list command or the properties command, it doesn't matter which one we get it from. We're going to get something that looks like this. Okay, this will list out all of the properties of that polyline. So at the very top here, it tells us what the area is and what the perimeter is. Okay, so that's important information. Okay, so that can be used for a variety of things. The other thing that's important about polylines is once you have a closed polyline, you can extrude it so it becomes a 3D shape. So if this was a flat piece of wood or steel or something, imagine this having thickness. Okay, right now it's not. If we look at it in 3D, for instance, if I kind of zoom at it like this, okay, we're in 3D right now and we can see that this is just a flat plate. As soon as I enter in the extrude command, EXT for extrude, I can pick this polyline, and when I do, I can give the polyline height like this, and it becomes a 3D object, and I can go ahead and shade this up here so we can kind of see it in 3D. So if I look around it, you can see that that is now a viable 3D shape. So it has its place in many different circumstances. So what else can we do here? Let's erase what we are doing and let's get back to home. Home, top, there we go. So we're back in 2D world here at the very beginning. So other things that a polyline is good for is arraying along a path. So for instance, if I have a polyline and we have something that looks like this, and we have an arc like this that's traveling, and then some lines that are going like this, okay, and I want this circle to be arrayed along that path. Okay, we're going to come in here to array, and we're going to do path array and array path. Okay, so select objects. Well, this is our path. Whoops, excuse me. This is our object we want to array, and then this is our path. Okay, so our path has to be a polyline, and we go ahead and put that on so we get something like that. So I can go ahead and change all my settings in there, and then I have that set up. Okay, so obviously that's an advantage to be able to do something like that. Okay, before the array command came along, let's go back at this for a second, look at this for a second. Right now in here we're doing a measured array, so basically it's 1.450 along that. So each one of these is measured from the start, okay, and each one is 0.145 between the centers, and whatever's left over here is whatever's left over. So if I change that number to say 0.25, okay, we have 1/4 inch every spacing. Okay, and this is determined right here under measure. If I come up here and change it to divide, okay, instead of having how many a distance between these objects, I have how many I want, and this is from the start point to the end point. So when I come in here, I can say, well, I only want 7, so it divides that into 7, or if I want 32, it divides it into 32, or whatever I want. Okay, so that is how that works. But if we come in and use a polyline again, And this time we'll do another kind of curvy one. Alright. And I have a block that I want to array along this path. So say it's you know, you're working on a survey plan and you have to put in fence posts or fences all along. You know, what I could do is basically draw a rectangle. Okay, and I'll just zoom up to it and I'll draw a line from end to end like this, and I'll put a circle in the middle, and we'll trim this out. Okay, so they have something like that. Okay, and what I'm going to do is make a block out of that, and so my block name is going to be post. My base point is going to be the center of that circle right there. Okay, I'll select my objects and I'll delete them. Okay, so then we'll come back to this thing right here. Okay, so we have two commands. One's called divide, one's called measure, and they are different than the array along a path in that you can use a block. So when I use, say, divide, I'll just type in divide, select the object I want to divide. I can say, okay, here's my polyline, I want to divide this. Notice that the command says divide, enter the number of segments or block, and I'm going to say, yeah, okay, block. Alright, I want to put in the post. Do you want to align the block with the object? And I'll say yes. How many segments do I want? I want 12. So I'll type in enter and I get 12 of these segments. Okay. Notice it doesn't put in the start or the end. I'm not sure why in this case, but you could go ahead and insert your post right there. Just kind of align it like that. Put in your post at the end. Oops. Align that one up like that. Just align it like that. And then when you're done, you can erase your polyline and you get that sort of thing. Okay. So let's use that same exact example again. Using the same polyline, we'll just copy it over to here. And this time we'll use the measure command. So we'll select the object to measure. Okay, B for block. What are we going to measure? The post. Align it, yes. Specify the length of the segment. Well, in this case here we'll go with 4. And ooh, it only put in 1. Why? Because the length from here to there is 4. So let's try that again. Let's do measure one more time. B for block. We're going to put in the post. We're going to align it, yes, and it's going to be 0.25. So this time we get from the start to there, and it puts it in all the way around. Okay. So, and I'm not sure why it's not putting that in at the beginning. It should be, because it should be putting in the start is right here. Okay, so from here to here should be 0.25, and from here to here is whatever's left over. Okay. So what happens when we answer no to that align question? Okay, so basically our blocks would be brought in the way that they were created. So if I type in post again and I say no to align, and this time 0.25, notice that my blocks are all going at an angle. Okay. So this has always been a great way to kind of make like railroad tracks and things like that. So, you know, you could just simply put in, say, a simple line. So if I just draw a simple line up and down like this, okay, and we'll just have that simple line, something like that, and we go ahead and make that a block. Call it track. its base point is going to be the midpoint of it. We'll select the object. Okay, delete it. And this time we'll do measure again. We'll select it. Block. We're going to use track. Align it this time or not. We'll say yes and see what happens. 0.25. Okay, so you can see how it's drawing it like that. If I did the opposite and do measure again, pick this one more time, block, and we do track, and we'll say no this time, 0.25, we get something that looks like that. Okay, so it's important to understand these little nuances between how all this sort of stuff works. So yeah, let me back up here a second and let's use the copy command again, and let's copy this little widget again like this. And I'm gonna come in here to my line types, and I'm gonna load, let's load up a hidden line, and let's load up this fence line square, or let's use the fence line circle, and hit OK. So this time I'll pick this one, and I'm going to go into its properties for a second, and we're going to change its line type to hidden. And this one I'm going to click this, and I'm going to change its line type, excuse me, to fence line 1. Okay, and nothing's good is happening here. Let's use line type scale, LT scale. Right now it's 1. If I go 0.5, it should be half, right? So we'll do that. So now I get something that looks like that. Really weird, right? Well, polylines have the ability to generate the line types correctly. So you can either use the pedit command or the properties. Okay, so if I use pedit, for instance, I can pick this polyline right here, and notice in my command line down bottom here we have this thing here that says line type gen. Okay, this means generate the line type to fit along the polyline. So when I do this and I say on, I get this nice evenly spaced hidden line. Same thing with this one. This time, instead of using pedit, I'll just select this and I'll come over here, and we'll look down through this. Okay, at the very bottom, line type generation is disabled. When I drop this down and say enabled, notice that our fence line is now spaced evenly, and this is a line type. This isn't a block. Okay, it's not like this one up here. So if I do LT scale again and set it even lower, like 0.25, okay, it's always going to be correct. All right, so each time you can see that, and that's how polyline line type generation can occur. Okay, so there's some things with line type, some blocks, some measure, divide, array along a path, all have to do with polylines. Okay, so let's erase some of this stuff, and the last thing that we'll do is look at varying widths of polylines. So if I have a polyline like this that's coming up, and we have an arc, and we kind of do this sort of thing. So we started here, we ended here. When I click on this, we can see that our grips, okay, are each vertex point. In between our grips is our stretch grip. When I pick that, I can actually stretch that out, okay? So, and I click on this, I can actually move that grip. Okay, so I can change my polyline shape, and when I pick the middle grip, notice that it will get all out of shape in there as far as its tangency. So you got to be careful with that a little bit. But what I want to show you here is using the pedit command, that you can go in here, and first off, under the pedit command, we have close. So when you have a polyline that's open like this, okay, it starts here, it ends here. If you want it to be a closed polyline, you type in C for close, and it will close it. Okay. Notice once I've closed it, the sub options change to open. So when I say open, it will reopen that up again. Okay. Obviously, you know what join is. Width, if we type in W for width, it'll change the whole entire width of this. So if I said, okay, I want it to be 0.1 in thickness, notice we get something like that. And when you have hard transitions from like an arc to another arc, occasionally you'll get these gaps like this, okay? And that's just the nature of the polyline. There's really nothing that can be done about that, okay? But let's just undo that for a second. And I want to kind of go back into Polyline Edit again. So the next option is Edit Vertex, okay, and then we have Split, Spline, Decurve. We've seen line type generation, and then there's Reverse and Undo, okay. The next option is Edit Vertex. This is where things can get a little bit complicated, all right. But if I type in E for Edit Vertex, the first thing that happens when I get Edit Vertex, I get an X right here. And notice that my options change down bottom. We have next, previous, break, insert, move, regen, straighten, tangent, width, and exit. Okay. So if I just, in the default right now is N for next. So if I just hit enter, that little X will go to the next vertex point. Okay, so those are all vertex points. And when I'm to the end and I keep hitting enter, nothing's happening. So if I hit P for previous, I can go to the previous vertex, so I can back up along that path. Okay. So at this point, I'm going to go N for next, like that, and I can go P for previous, and I can back up and go back and forth. All right. And if I type in E or X for exit, it exits me out like that. All right. So I'm going to edit my vertexes like this. So we're going to go ahead and change the width from tapered width, starting at a tapering. So if I type in W for width, the starting width, notice what it says, specify starting width for next segment is 0. So this is talking about where it starts right here. I'm going to leave it at 0. And then specify the ending width for the next segment. Well, the next segment's going to go up here to this vertex point. So what do I want that to be? Well, I want it to be 1. So what I'll get is a tapering like that. Okay. And then if I say N for next, it puts my X up here like that. Okay. So what if I want this width to now taper from this width of 1 back down to 0? I could type in W for width again, and my starting width is 1, my ending width is 0, and that's what I end up with, is something that looks like that. Okay, so then I can say, okay, I'm going to go next again, and this time I'm going to say W for width is going to be 0, and my next segment width is going to be, say, 0.25. Okay, so then I'll go to my next vertex point, and I can say W for width 0.25, which is going to be the same, and ending at 0.25 like that. All right, I can go next, and then I'll just use 0.25 going along the rest of this. So we'll do 0.25 to 25, go next, you got to do width 0.25, 0.25, and then next. And this one here, I want it to taper out, so I'll do width 0.25 back to 0, and I'll do X for exit, and I'll escape out of the command. So in this case here, you can see how that works, and in this case here we get this gap. Can't really do anything about it. I can't believe Autodesk hasn't fixed this after all these years, but it doesn't understand how to close that up. If you had to close that up, then what I would do is I'd draw a little arc in there and fill that in with a solid hatch pattern, which, you know, is a pain, but that's just the way it is. On very extreme angles, it just doesn't know what to do. So you could, in fact, try to change it a little bit if you actually went in here and adjusted the arc of this to something like that. And you can see then it kind of gets screwed up again. But anyway, so that's basically how you can taper widths. Okay, so so other useful things with polylines are like this. If I come in here and I just draw a simple kind of up and down pattern like this, I want to show you something like that. And I'm just going to copy this. I call it my Charlie Brown zigzags. Okay, so we have these kind of things like that. If I use P-Edit on the second one, if I use the sub option F for fit, what this does is it will fit a curve between each vertex point, and it holds the vertex point. So this vertex point, and this vertex point are all held, and if you move this up on top of this so that you can kind of see it, okay, you can kind of see, well, let's do it more accurately. I'll just use the endpoint here. They share the same exact endpoints. So when I do that, you can see how it fits a curve between each one of the vertex points. Okay, so that's one way to smooth out a polyline. If you use P-Edit again and pick this one, and then this time you use spline curve, what this does is it averages out the polyline. So when I click this endpoint and put it on here, you can see what it does is it averages out a curve between all the vertex points. So there's a difference there in how these are generated. So, and when you have a curve like this, okay, this is typically the way that like contours are drawn on a map. Okay, problem with this is that the line types are the problem, and I've already showed you how to alleviate that, but you have to make sure that your line type generation is set on for it to show up with hidden lines, especially in a spline curve, because in these types of curves, if I set this line type in here to hidden, okay, it's going to look really, really weird. So LT scale, and we'll go back to 1. Okay, so with a line type scale of 1, we just get one dashed line in here. So you can see that obviously you want to make sure that you have that line type generation on. Okay, right here it's disabled, so we'll say enabled, and that we'll put that in there like that. Okay. Also notice that you get the frame on the spline curve, and on the fit curve you don't. You get the grips on here to actually change. You know, you can change the vertex point like that. It's going to hold the first one, it's going to hold the second one, but this one here will change. In here you're changing the actual frame itself. You can kind of see how that works. It's using the frame itself, because this is what we call the Bezier curve. And there are different Bezier curve setups in AutoCAD. There's a quadratic spline and a cubic spline, and all those types of things. And it's a variable. So the system variable that you're going to use is called spline type. So SPLIN type, spline type, and you either have a 5 or a 6. A 5 is a quadratic spline, and a 6 is a cubic spline. So the one that I just drew up here is a quadratic spline, which is a 6. If I put in 5, and we just copy this again, now we'll copy this original one down, and we'll p-edit this, and we'll spline it. You can see it's a little bit different. Okay, so that's a spline type of 5. Okay, and let's just copy this again so you can see it. And it's just a different type of spline curve. That's all it is, really. Okay, so if we use spline type and set that back to 5, and p-edit this one. Oops, that's the same one. Undo that, sorry. Spline type, and we'll do 6 this time. So you can see 6 is more subtle and 5 is a little bit more pronounced. Okay, and there's one other variable that has to do with splines, and that is the spline edges, because basically what happens if you explode one of these splines, and you zoom right up to it, you can see the spline is made up of individual little tiny line segments. It's not actually made up of arcs at all. So if you accidentally explode one of these, gonna be a little bit of a lot of lines. So if I explode this, we have these little tiny lines in here. Okay, so this little tiny lines. So a polyline that went from, say, 1, 2, 4, 6, 8, 10 lines, okay, is going to end up, once it gets splined, being, let's see, if we erase this, we'll see how many. There's 72 little tiny line segments in there. So that's why if you're ever working on a contour plan on a topography map and you explode a polyline on there, your drawing ends up becoming really huge. Okay, so there's a variable that controls this. So by default, the spline, or what they call spline edges, is set to 8 segments in between these. So if we make another couple copies of this, you know, we have something like this, and we use p-edit on this one and just spline it. Okay, and then I use the system variable called spline segments. Okay, spline segs. Okay, and right now it's set to 8, and I believe I don't believe that this has a upper or lower value. I can't remember, but let's see if I put it up to 256. Yeah, it took that. Let's go up to 2000. Yeah, it took 2000. So it'll take, you know, so you can make these very intense. So let's do that one here. We'll do this one, and we'll pick that, and we'll spline it out. Okay, so this one has 2000 spline segments in it. This one has 8 spline segments. So let's explode them to just kind of see what happens. All right, so we'll explode that one and explode that one. Okay, when we go to erase this one, we have 64 segments. When we go to erase this one, we have 16,000 segments. So there's a lot of little lines in there. All right, and then on the other end of this, if we set that same variable, spline segments, to say 3, and do a p-edit on this again, and we go in here and spline this out, see how jaggedy looking it gets? Okay, it's not going to be smooth at all. So so you have to know, you know, what that variable is and what it does. So spline segments, I'd just leave it alone at 8, but I'm just letting you know so that you know all of the different options out there. Okay, so anyhow, let's erase all of the junk that we have on the screen. All right, so lastly here, we're going to do one more thing with a polyline, and I'm just going to kind of draw a polyline that looks like this. All right, and we're going to use Polyline Edit again. Go back into Polyline Edit, and we're going to edit the vertex one more time. And this time we're going to go up to this segment here, and we're going to insert a new vertex point, because occasionally you may have a case where you may want to, you know, put in another vertex point, like we want to come down and then go back up. So I can say I for insert, and then I can actually come in here and specify where I want to insert the next point, and it'll put that point in, and then I can either go to the next point or get done and hit exit. And we can also do things like break a segment in here, we can move a segment, we can straighten a segment, and we can make things tangent or not. So for instance, if we come in here and say P for previous, and I say S for straighten, okay, I want to straighten from that point to the next, okay, and then I type in G for go, and it will straighten that back up out again. Okay, so that's what that does. And if I go P for previous and go N for next, and I want to break out a segment, but first I'm going to insert a couple. Let's see, we'll insert, and I'll insert, and I'll insert like that, and I'll go back previous, and I'll say, okay, I want to break. Okay, so I'll go next, and then I'll say G for go. It'll break that out. So if I go next, we have 2 separate polylines now. So when I get out of the command and exit, okay, this is a polyline, this is a polyline. They're no longer connected up. I don't really understand why that's in there, because you can just use the break command anyway. If I went in here and just use the break command, I can go pick, and it'll break that in there anyway. So not a big deal. So that pretty much takes us through polylines. I hope you have fun playing with them.